Welcome back. I'm David. This is SciTales. Here's a question that sounds simple, but isn't. What happens if you fall into a black hole? Not you die. Everyone knows that part. What actually happens physically on the way down? Today, we're explaining black holes in plain, simple words. What they really are, what falling in would actually feel like, and a discovery from this year that suggests some black holes have secret pasts. Segment 1. Let's start with what a black hole actually is. A black hole isn't a hole. It's a star's leftover core, crushed down so tightly that its gravity becomes inescapable. When a massive enough star runs out of fuel, it can no longer hold itself up against its own weight. It collapses, not a little, but completely, down to a single point where all that mass exists in essentially zero space. That crushing creates something extreme, gravity so strong that not even light, the fastest thing in existence, can escape it. The boundary where escape becomes impossible is called the event horizon. It's not a physical surface. It's simply the last line where turning back is still possible. Here's a way to picture it. Imagine gravity as a slope you're always sliding down. Near a black hole, that slope gets steeper and steeper. Cross the event horizon, and the slope becomes vertical. Every direction, including forward, points down. There's no more away left to move toward. Segment 2. So what would actually happen to you? Long before you'd reach the event horizon, gravity would already be pulling harder on your feet than your head, if you went in feet first. Stretch that difference far enough, and it would stretch you too. A real effect scientists actually call, only half-jokingly, spaghettification. For a small black hole, that stretching happens fast and violently, long before you reach the horizon. But for a supermassive black hole, the kind sitting at the center of galaxies like ours, the horizon is so large that the pull is gentler there. You could, in theory, cross it without feeling anything unusual in the moment. That's the strange part. Crossing the event horizon isn't a bang, a flash, or a wall. From your own perspective, nothing marks the crossing at all. It's only afterward, once return is already impossible, that the situation becomes irreversible. Segment 3. And now, the discovery that makes this episode worth making right now. This July, physicists at MIT published a study built on the largest catalog of black hole collisions ever assembled. And they found something surprising hiding in the data. Some of the black holes merging together weren't simple, first-generation remnants of dying stars at all. They showed the fingerprints of already being merger products themselves, black holes formed from an earlier collision of two smaller black holes, colliding yet again. In other words, some black holes we're detecting have already lived one whole collision lifetime before the one we're watching. Scientists call this hierarchical formation, smaller black holes. Combining, then combining again, building up mass step by step across generations, rather than every black hole tracing back to a single collapsed star. This matters because it helps answer a real puzzle. Some black holes are heavier than a single star's collapse should be able to produce. A history of repeated mergers offers one explanation for where that extra mass came from. Not one dramatic collapse, but a chain of them. Segment 4. So why should any of this matter to someone who isn't an astrophysicist? Because black holes aren't just cosmic curiosities sitting at a safe distance. There's very likely one at the center of our own galaxy, quietly anchoring the orbits of everything around it, including, indirectly, us. And every time gravitational wave detectors catch two black holes colliding, They're recording something the fastest thing in the universe. Light. Literally cannot show us. Gravity itself becomes the messenger. Let's bring it home, in plain words. A black hole is a collapsed star crushed past the point of return, with a boundary where gravity becomes inescapable, not a physical wall. Falling in wouldn't necessarily feel dramatic. For the biggest black holes, the crossing itself might feel like nothing at all. And this year, scientists found real evidence that some black holes carry a merger history stretching back generations, one collision building on the last. Science isn't about staring into a single static mystery forever. It's about slowly learning to read the fingerprints objects leave behind, even objects that swallow light itself. Next episode, we're staying close to home this time. The strange physics hiding inside your own body. I'm David. Thanks for listening. Stay curious.